Hello, everybody. My name is Undergraduate. I'm from the University of Memphis, and I'll be presenting the poster for the Seismic Design Competition for 2021. So the problem that was given to us was we had an existing structure that was a hospital that wanted to expand due to the COVID pandemic. And essentially the things that were looked at when designing the existing structure was if the existing structure could handle seismic loading because it was in the Seattle area, which is prone to seismicity, and also we don't know if the structure was designed for seismic effects because it's a very old structure. And if it will be able to handle the addition without any retrofits, and if the addition structure would need retrofitting and where those retrofits would need to occur to be able to withstand such earthquakes. Time histories were provided by the SLC. And we use the National Design specification for wood construction to determine capacities of modeling members of like balsa wood. So the architectural design, essentially we had for the retrofitted structure, we had balconies for the actual structure, as you can see here. It was 19 stories high, went all the way to the top, and provides over 2,000 square inches of floor area. The bottom floor was already an existing structure, but it was doubled to allow for aesthetics appeals and entrances. And we combined both conventional X and super bracing to have more of a unique design and aesthetic appeal. And it produced very well structurally. So the structural design, we used both super bracing and X bracing. So we utilize X bracing in the addition of the structure, and we wanted that X bracing to be taking the load path of the top of the new addition into the existing X bracing on the west facade. And then we utilize super bracing in the retrofitting aspect because we wanted to limit the amount of members that would have to be going into the structure. And also by limiting them, you would also want to increase your strength. So using that, we determined previously that super bracing has a higher strength to weight ratio. So you have less members, less weight, and you have a higher strength. So who wouldn't want that? So the structural design thing that we wanted to keep in mind was the internal moment occurring on within the structure. The internal moment is due to a fictitious force of acceleration on the ground earthquake. So essentially when we were looking at the structure, the existing structure, we wanted to make sure that the existing structure didn't have any failure modes, which we believe it did have some failure modes, but we did not determine if it would collapse or not. And then from the existing structure to the addition structure, we tried to best implement the design to where it wouldn't excite any already failed members or anything like that. So what we did was we took the bracing and extend all the X bracing at the top of the addition and extended it back to the already existing west facade and X bracing that already exists there to mitigate the strains and forces that would occur in the additions of the structure and mitigate the strains and forces that would occur on the non-brace side. So in the retrofitting of the structure, we decided that this entire east side needed to be retrofitted, as well as we decided to make the west side of the north facade also symmetrical to the other side, giving it a more rigid structure. And we utilize a super bracing on the west facade where there was originally no super bracing. My bad, not on the west side, on the east side of the facade. So here we have our roof displacement for time history occurring in the north and south direction, and we also have our roof acceleration in inches per second squared. And we also have our internal forces for the retrofitted structure for axial forces for the east and north elevations. Thank you. Have a good day.